this is a perfect link to our mission. Our mission really is to drive speed and accelerate this field, the innovation in this field, through fundamental understanding of cell technology.
The one thing that all our clients and partners have in common is they're always too late. Right? Everybody says, guys, we're too late. We're already per default behind. We need to speed up. We need to accelerate. And I think that's where the market needs a lot of support at the moment.
Welcome back to In Between Charges. This is the perfect podcast to listen to whilst waiting for your EV to charge. I'm Mike Hawkes, and as always, I'm joined by my co-host, Kevin Spangenberg. Kevin, welcome back. Happy Halloween.
Happy Halloween. Where's your costume?
You can't tell? It's already on?
I don't know what you are.
Okay, all right.
So no, I can't tell.
Now, today we have a very special podcast for everybody. We are here in the studio in person, and we're joined by, all the way from the beautiful country of Switzerland, here in the Monta showroom, two very special guests, Luca Scherrer and Lutz, the co-founders of S2E2 Energy. Welcome both.
Thank you
Thanks for having us.
How was the trip over? I think for people who can't see us, it's very wet and windy outside.
Better for me than for Lukas, that's for sure.
I almost missed my connection flight, but I lucky to made it.
No, we're glad you made it here.
Or unlucky, given the weather. But
Great, let's get started. So I think maybe firstly, just to kind of kick us off, right? Batteries, mega trend for the next decade. I think everybody agrees. Whether it's lithium ion, it's something that's necessary for the electrification now and in the future. And we really think you're onto something here, of course, based on the EV space. A big part of that is the battery that's in the vehicle. But could you share with us a little bit about why you started S2E2 Energy and what was the original problem that you tried to solve for?
So S2E's mission was always to accelerate the battery field, so the battery production side of it, but also the development of battery-powered products to accelerate these players through deeper understanding, more insights about the battery cell. We believe that a detailed understanding and insights about this cell technology, which is the most fundamental component of any battery system, that such a fundamental understanding is required to enable the right technical decisions, but also the right strategic decisions. And with this mission, we kind of grew with the market, right? We started with developing test solutions for next generation batteries, and now really see ourselves as a technology advisory firm for the entire battery value chain. So for battery producers, but also battery buyers, OEMs, micromobility providers, energy storage system providers, but also any industry really that is trying to serve this exciting market. So that's really the foundation of what we do. On top of that, we also offer and provide advisory services, really from innovation scouting to LCA sustainability assessment. And then on top of this really cool data that we collect through those services, we are now able to provide data and AI services and products. And that's one of the main reasons we are here today, other than the great weather, of course.
maybe, Lucas, you could talk a little bit about how that battery value chain has really evolved or developed in the last 5 to 10 years, right? I know you've been founded in 2018, but with the introduction of so many more batteries into our grid, into our daily lives, like how is that really changing right now from the way it was 10 or 15 years ago?
Yeah, that's a very, very good one. I think people have dramatically underestimated the impact the battery has on the entire market. Not only on EVs, right there, it became pretty clear that it changes profoundly the business model, but also the organization of the OEMs. But also a lot of other markets, and also in the talent market, it had a profound impact, the battery. So I think from your question was, I think back then the battery technology was really something more on a science level, right? And now what has changed, it had really come to everybody's home. Now we're looking at home storage. I think a lot of new businesses grew around that. Everybody has now the opportunity to create their own electricity just because you can store it locally as well. We have a big infrastructure challenge as well, right? We have to really change how our electricity grid is working. So it had really profound impacts on business models of different industries, but also on us as end consumers, and also on a political or an infrastructure side. I think it's a really great trend towards a greener and more sustainable future, but it's also a tough one to implement in the end.
Could you give us a specific example about how the value chain for a specific industry has been impacted by the change in technology of batteries, the change of price, and perhaps the mix of raw materials, but also the change in consumer behavior?
Sure. I mean, since we're here in an EV podcast, probably the EV is a good example to start with. I mean, being an automaker in these times is not trivial, right? Because first of all, you lost one of the most important core competencies within your company, which is the internal combustion engine, right? You had to change this to an electric motor and to a battery pack. So starting there, you had to somehow find a supplier for batteries where there's simply not a lot in Europe. That's the first stress on the value chain in the end. For the OEMs, they had a pretty big impact because they were used to having a lot of power over their supply chain. And that changed pretty dramatically into the supplier had a lot of power out of a sudden. The big, especially Asian players in the market kind of dictated what batteries are available to which price. So that's where it starts in the supply chain. But then also, you were asking about consumer behavior, right? Out of the sudden, you have a completely different product in the market. The internal combustion engine car, the ICE car, was really well understood. But now out of the sudden, the end customer has a different perception of this product, right? He or she needs to think about, how do I use it? Do I have a charging station at home? What's the electricity price, especially in Germany right now? That messes up pretty much the business model of the OEMs. But also then questions, going back to the value chain, what happens to the car after its use, right? When is the EV life at an end? Is it the 80% that everybody's talking about, or what happens after that? Nobody knows. So there is a lot of uncertainty mixed with supply stress, right? Where do you get your materials from? And on top of that, there is the consumer that wants a lot of mileage, a cheap price, and the OEM simply doesn't have it in their own hands. They're really dependent on a lot of other parties for that.
Amazing. So maybe you mentioned a couple of kind of big questions there. A couple of them that also, once answered, will take the industry within a certain direction. So you're talking about where we're actually sourcing the raw materials from, for example. What happens to the battery at the end of an EV's life? Who's actually going to be making that decision? Is it the OEM? Is it actually the consumer? Who overall owns that choice? So it'd be great if we could perhaps talk about each of the major challenges in turn and take it one by one and just really understand, because there's a lot of things that's happening. And likewise, in the software space, in the EV industry, we see these hard forks occur almost on a monthly basis. So the first one, when it comes to batteries, just feels like it's always the elephant in the room, essentially battery and raw material supply. And just to kind of paint a picture, I think this is already data that you have probably seen. So global demand for raw materials, and that is nickel, graphite, lithium, maybe not necessarily cobalt, depending on the actually battery structure that would be decided, projected to increase by 2040 by 20 times, 19 times, and 14 times respective of those various different chemicals. And then also China is going to continue to be the major supplier of a lot of those materials as well. So organizations in the US and Europe have to also try to create some protective or defensive strategies to maximize what they're getting through. So what challenges do you see on the horizon? And then also maybe what role should consumers play in making informed choices in what type of batteries they're actually choosing now, whether it's an EV or whether it's a tool, for example, in the house?
That's a great question. And I don't think we have the silver bullet answer for this question, right? I think what's evident for everyone is that we are highly dependent on Asia in any of these steps. If it's now the sourcing, everyone talks about the mining. 60-ish% I think is driven and owned by Asian players. But then we also have the refining of these raw materials, and often this is forgotten in the discussions. And I think, what is it, Lukas? The graphite refinery is the anode, obviously one of the key components of a battery, is owned 90% by China. So I think when we talk about sourcing raw materials, before answering your questions, we also need to talk about refining of those raw materials. And again, there, I think the dependency on Asia and those Asian players is just, it's insane.
And maybe a recent example that's not so long ago, when you look what happened to Northvolt, who is one of the major cell manufacturers within Europe, it seems like they became a real threat to the Chinese. And as soon as this happened, they just cut all the export of graphite to Sweden in that case. So there was no more graphite being supplied, which put such a cell manufacturer in big trouble, right? They're out of a sudden, they would have never expected this. And now you need to look for a new graphite supply where China owns 90% of it. So the price will certainly increase. You're having a lot of stress right now because you need to find an alternative supplier. And they play this game very well, right? They know exactly how long they let us play and when they need to pull the trigger on something that hurts us quite badly.
And maybe what is the solution to that? I mean, obviously, it's a hard, difficult question to answer, but one answer needs to be recycling, right? We need to keep those raw materials that we already have here within our country, within our control. And I think that brings us probably to the topic, ownership of the battery, access to the battery of the OEM, right? Whereas before, the OEM wasn't really interested in controlling, accessing, say, a turbocharger. Whereas now, the OEM wants to access and control this battery along the entire value chain because of the access to raw materials, regulatory reasons, but also other reasons such as cost planning, for example. And access to this raw material in general.
And I think the question here is really that nobody wants to talk about is who pays for that? Because there is a strategic value to these raw materials that is not an absolute value currently, right? At the end of life, a battery has a certain value. We're working a lot with determining what the residual value of an EV and specifically of the battery is. But there is a lot of cost involved there of transportation, dismantling, and all that stuff. And in the end, there's not much left over, to be fully honest. And if you're moving to specific cell chemistries that don't use nickel, don't use cobalt, don't use manganese, then it's even more difficult to come up with a residual price that's actually worth something. And then there must be the question, who pays for all that? If there is a strategic value to it, and we need to think about who's in the end responsible for such a strategic asset.
So is your approach by companies in the industry now who are trying to answer that question? I mean, how do you answer that question for them?
So we take a data-driven approach to that. We are trying to, model different data sources that we have available together with OEMs in the market to come up with an algorithm that allows you to take better decisions on the residual value of a battery.
And it's actually interesting. You can see how little understood this field is by the fact that there is simply no insurance for an EV battery. You can insure your EV, but if you read the small letters at the bottom of the contract, it excludes the battery, right? This is simply because no one has the risk models, nobody has the experience yet to determine the cost of a refurbishment or the residual value of the battery.
Yeah, I think that's a fascinating topic. And also because now a lot of the manufacturers have designed batteries without the need for the recycling regulations, etc. So the batteries that will be coming out that actually could be recycled or have a second life will really start to come out kind of later towards closer to 2030, around 2027, 2028 or so. So that industry also doesn't necessarily exist yet.
Do you guys have a solution for the battery insurance question, or do you deal with the secondhand batteries? I have a good friend back home who just bought a secondhand Tesla, and he feels like his battery is not great. What should someone do if they're looking to buy a secondhand electric vehicle if they want to ensure the quality of their battery?
That's exactly the question we're working on right now. And we're not looking at it only from an aging perspective, but to determine the residual value of a battery at the end of life, you need to look at all the market parameters as well. What are raw material prices? What are cost of recycling, refurbishment? Refurbishment can be anything between 5,000 and 15,000 euros depending on the car. So there's a big difference there. And this is all parameters you need to look into when you want to determine the residual value of an EV or of a battery. To answer your question, when you buy a second-hand EV, I think it's pretty challenging at the moment because some cars, like Mercedes Me app, I think they have a kind of tracker of your state of health. But the state of health, it's a nice segue actually to why we think this understanding, the fundamental understanding of cell chemistry is so important to all of that, because you need to really understand what does state of health mean. State of health in common words is always only this percentage of the original capacity, right? But there is so much more to it. You can have still 70% of the original capacity, but if you were doing that with fast charging all the time, your battery has more age than a battery that was charged normally.
That's an interesting one. So do you have any kind of insight on what that degradation actually looks like? I guess an industry spoken time is around 10 years for some sort of degradation, but these are high quality batteries that are built for range, they're built for performance on a daily basis. I mean, how do you see that degrading so far in some of the data, the performance?
Yeah, so it really depends on the cell chemistry. There is no generic answer to that, but it really depends on the cell chemistry. And we're working a lot right now with the phenomenon called plating, which is when you have the ions in a lithium-ion battery, the ions move from the anode to the cathode, right? And during charging, they move to the anode. And when they intercalate in this mostly graphite, so some carbon compound, you can imagine it as a sponge. And when these ions come there, and you apply a lot of current, it's like a traffic jam, basically. A lot of ions want to move into the same hole at the same time. And this can lead to a phenomenon called plating, plating, where you basically plate metallic lithium at a certain point. And from this, then these detrimental dendrites can grow, which is like a ice, what's it called?
Like a spike that comes out, basically?
Exactly.
Okay, we were talking about this a little bit just before the podcast.
That's it. Exactly. That's the word.
Stalactite or stalagmite? Which one is the one that
Stalactite is it?
Stalactites on the floor, right? And then stalagmites on the...
Yeah. So this is a phenomenon that really comes through fast charging. And now automakers are just about to understand what is the different scenarios, how many fast charging cycles I can allow for the batteries to not degrade, how much is reversible, how much irreversible. And that's kind of a completely new field that was, again, driven through the customer behavior. And it's kind of contradictory, right? You want to charge fast, but you want to have a long life and a good residual value. So it's the battery is full of trade-offs, let's put it that way.
And maybe to tie this back to the question you initially asked, right? How can we understand the value, the residual value of an EV or of a second life EV? And I think we see a lot of startups popping up now offering these quick checks that quickly assess the state of health of your battery. They're fine, right? They're definitely needed. But we believe that a breakthrough solution to this problem, to these challenges, must be driven through the OEM. Why? Only the OEM has access to exactly this understanding of the cell, right? Only the OEM has data about their cell in different conditions, under different parameters.
Does it have anything to do with Coulombic efficiency? Is that right?
Yeah. I mean,
it's a lot of smiles, a lot of nods in the room. It sounds like it's exactly
I learned that word 30 minutes ago.
Well done, Kevin.
well researched.
Was it part of your Halloween costume?
Yeah. No, it was not. It was. We have a colleague who's into batteries, and I said, "Hey, can you give me something to throw at these guys?" And he said, "Coulombic efficiency." Maybe you can explain what that is a little bit.
Yeah, so it's basically how much charge you can put in and out of a battery. And there is a theoretical 100%. And when you really count the coulombs, so the electrons that you pump in, let's say a battery has at the initial state 100 electrons that you can pump in, and your Coulombic efficiency is only at 80%. That means you can only charge and discharge 80 of these 100 electrons, because these other 20 electrons maybe went into degrading the electrolyte rather than coming out through as current again. So that's basically a way to determine the depth of degradation, so to say.
Very accurate way. Maybe the most accurate way of doing that, yeah.
Surely there must be some data on this about lithium ion or solid state, what the average benchmark is and how quickly that degrades. I mean, do you have anything that you can share with us, what you've seen so far from some of your analysis?
Yes.
I don't think a general answer to this is possible. Okay. Sorry, Mike.
I mean, that's where it gets complicated, right? Because it really depends on, okay, what anode chemistry do you have? What cathode chemistry? I don't want to become too scientific now, but it is a crazy complex topic and it's a crazy complex technology. And I think we need to start to acknowledge that, and that will prevent us also from believing in these holy grails and hypes that are everywhere in the news.
But that makes me think about how we bring this to the everyday consumer a little bit, right? We're in an adjacent industry, and we enjoy talking about this with you all, but your everyday consumer wants to go and buy an EV, either a new one or a used one, and have some app or some way to guarantee that this battery is going to do what it says it will do on the sticker, right? Who do you need to educate? You talked about the OEM, or you talk about maybe the car dealership owner or whoever it is, right? How do we simplify it for everybody a little bit and make the ownership of an EV a positive and easy experience?
Yeah, I think that's the work we have to do. I completely agree. But it needs to start by understanding the fundamental of a chemistry, of the cell chemistry, of the cell itself. And how can we then simplify it for the end user? That's, I think, the second step. But I completely agree with you. That's the end goal.
Yeah, I think it's just also such a new technology. I mean, batteries have been around for a long time, but this whole EV trend is less than a decade old. And it's just, we're in the beginning of something, right? That's what I always have as a topic when we talk to our clients. They're under so much pressure from all sides, right? They need to produce at cost, highly innovative, new cell tech, everything at the same time. And then obviously the consumer says, but this is all way too complex for me. I want it simple. I want to understand it. But we're really in a dramatic change of technology right now. And this simply needs time.
But I think this is a perfect, link to our mission, right?
Yeah.
Our mission really is to drive speed and accelerate this field, the innovation in this field, through fundamental understanding of cell technology.
The one thing that all our clients and partners have in common is they're always too late, right? Everybody says, guys, we're too late. We're already per default behind. We need to speed up. We need to accelerate. And I think that's where the market needs a lot of support at the moment.
So we talked about challenge one, raw material supply. We started also to chat a little bit about residual EVs. Maybe this is a good segue then. So you talked a little bit about organizations who have already made decisions or are about to make decisions essentially about what their investment strategy should be in battery technology and trying to get essentially the longest life, the biggest bang for their buck, right? So could you tell us a little bit about what you believe maybe the kind of sweet spot of performance is versus cost, and maybe a bit more details into the differences between the battery chemistries themselves?
So first of all, lithium-ion batteries is everything that has a lithium ion inside, no matter if it's solid state or liquid. Then there's a second category, which is sodium ion, which basically cycles a different ion, which is sodium in that case. And just to clarify that these are the two big buckets, right? There's pros and cons to both. A lot of claims out there that it's cheaper because it's obviously made from salt, in parentheses, which is kind of true, but still there is no established supply chain for all the raw materials, for all the precursors, which make it, in my eyes at least, tough to judge if it's really cheaper or not. In terms of performance, it's definitely weaker than the classical lithium-ion battery. And if we talk a little bit about the lithium-ion battery, so there's different chemistries within the lithium-ion battery bucket. The two major ones are NMC batteries, so nickel, manganese, cobalt batteries. And then there is the LFP, so lithium iron phosphate batteries. The NMC battery is more the high performance, fast charge, higher energy density chemistry. Comes along also more aggressively, so it has way more potential to burn, way more energy is stored in there, which makes it by default more aggressive as a chemistry. On the other side, the LFP chemistry is more used currently, at least in the energy storage systems. It's way cheaper because it doesn't use nickel, manganese, or cobalt. It just uses iron phosphate, which is rust. It has less energy density and it's very difficult to control. So for a battery management system, it's very hard to determine at which state of charge am I actually currently, right? We see LFP chemistry, so the lithium iron phosphate, coming more and more in the EV industry as well, especially for cheaper cars and cheaper applications, mainly driven through China. There was crazy stock market hypes around QuantumScape, Solid Power, and all these firms with tremendous claims, right? I don't know what they were, like 10 times more energy density, 3 times faster charging, whatnot.
I might have invested in the QuantumScape spec at some point.
I hope at the right time. You probably
I got out early. Don't worry. I've messed up some other specs, but I got out early on that one. Don't worry.
All right. I mean, Volkswagen did it as well, so why not you, right? That was kind of their market story there. No, but jokes aside, I mean, the solid state chemistry has theoretically one advantage. It eliminates the liquid electrolyte within the battery, which is usually a flammable chemical liquid substance, which should make it inherently safer. There's a lot of debate going on right now, if that's the case.
So just as an example, so when someone plugs in whatever it is, their phone or their device, if there's too much power going through, it's essentially not able to...
No,
what's the impact on the
battery? Right now we are limited. So at 4.2 volt, I think it's at 4.3 volt, every battery is kind of capped, so it doesn't allow to, it's not going higher. And if you want to implement cathode chemistries or anode chemistries, especially the anode here is the main field of research, but it's insanely complex. And that's what all the QuantumScapes found out, right? It's one thing to produce a mini coin cell in a lab, and it's another thing to scale up to a large format and produce stuff in large quantities.
Well, that's what made the Toyota stock pop like a month and a half ago, right? They said they'd made a breakthrough there. Do you believe it, or is that still some way off? What's the update there? Do you know?
So the solid state chemistries will come. I truly believe in that. But it won't come as promised. There's many sub-technologies under the umbrella of solid-state chemistries. One of them is called polymer, using polymer electrolytes, which is a kind of a hybrid system, right? It's not fully solid, but it's kind of solid. So a joke in the science community is almost solid-state batteries. But they are pretty advanced, and I think there will be the first prototypes coming out there and the first cars rolling in the next 2-3 years. Do I believe that's a mass product? No. I think it will be maybe for Porsche, maybe for Lamborghini, but certainly not a mass product. And it's way too expensive to manufacture. Cost will be the main driver in the next couple of years. So I don't think anybody should bet its strategy on solid-state batteries.
I think the key word there is trade-off, right? Lukas mentioned the trade-off between performance and energy. There is a trade-off between performance and cost, obviously. And then there's a third dimension, or a fourth in this case, which is sustainability. And I think that's an interesting development observation we see in cars at OEMs. Obviously, the German engineers, they want to optimize the cars for performance. So they put a lot of batteries even in the chassis to maximize the energy density within a car. But then what we're forgetting, and this ties back to the discussion we had before, how do we disassemble this car, right? It's now a high energy car optimized for performance, but how do you take off or service this battery, if at all?
Yeah, that's actually one thing I wanted to bring up was kind of the modularity versus integrated manufacturing kind of conundrum, right? As you see some of the OEMs trending towards the integrated piece, right? And making it like a laptop. But in that case, you're locking everything in and you're not able to replace that battery. And is that sustainable? One might argue no, right? Because it'd be great if a lot of these batteries are sometimes outliving the body of the car, right? And so if you could pop that battery out and put it into a new car, that could be a sustainable way of reusing these vehicles, right?
Correct. Yeah, I mean, definitely. That's one strategy. Yeah. I think we're going to see a lot of different approaches, a lot of different strategies. We're already seeing that, right, with the swappable system, for example. But there again, there is no... Sorry for using the term again, silver bullet. No. But I think we're going to see a lot of different strategies how to...
We don't like swappable batteries here at Monta because then we don't have any charge points to connect to. So
I thought you were going to say you don't like silver bullets as well. No, that's just what we're about.
I like silver bullets.
Doesn't like silver bullets.
I don't like battery swapping.
No, but also the battery swapping, right? It sounds amazing on paper, but then when you think like there's a swapping station, there's 5 cars ahead of you, and then you're also waiting your 30 minutes until you get your battery swapped. It's just an engineering challenge where I don't see a solution to. You can just manufacture a battery pack so much more efficiently into a car than if you have an exchangeable system where you need connectors, you need space, you need handles and all that stuff. That's just all volumetric or gravimetric energy density that you use.
Yeah, definitely. And also with battery swapping as well, I mean, how do you even guarantee the quality of the battery that you're actually getting in the vehicle? So you also have I would imagine you have a range of performance as well, depending on what battery you get. And then you just have to go through and swap it.
So we've talked about a few different challenges and dilemmas that everyone in our industry is trying to solve and understand this battery, not problem, but really like how does this fit in, right? You touched on one significant challenge is kind of a lack of talent, a lack of knowledge, right? Because this is just picking up so much recently that a lot of people are trying to really understand it. And just, in the last 5-10 years, we've got our top engineers that are finally looking at this and top companies beginning to sprout up and try to really provide context and understanding for all of this. How do we fundamentally address and confront the battery challenges that are in front of us?
I mean, excellent question. Yeah, I couldn't agree more. There is a lack of talent, especially in Europe and the West, in the whole battery field. How can we really speed up our knowledge base and our expert base here in the West, to say? And obviously, this makes us also always a step behind, right? We spoke about the lack of speed, and we don't have time to now, educate our people for generations to become battery experts. And we believe, new technologies out there. New AI developments in the last months, years are a key driver that we need to really leverage in order to make up for this gap.
But there's another point to that. We have never produced so much data in this field, and especially the batteries. I mean, you guys, you know that better than us. You're producing tons of data, right? And if we look at the manufacturing of batteries or at the manufacturing of battery-powered products, it's full of data. It's interconnected data. It's the data of the usage of the car needs to be linked to the cell chemistry and how it was produced, how the pack was assembled. But even more important is that it should be connected to each other to better understand the underlying phenomena that help us basically to produce a better product in the end. And I think these two things together is just simply something we can't solve as humans alone. When a big OEM starts a battery benchmarking, a battery cell, to be precise, benchmarking project, we're talking about terabytes of data. which costs them a lot of money, right? Cell testing is very expensive, it's very tedious. And then you have finally found your supplier that tests for you the batteries, you get all this information, and then who deals with that flood of information?
And we believe AI needs to play a crucial role in driving value for us, driving speed for the battery field. It's a logical consequence that we need to leverage these new tools in making us faster. It's really accessing and interacting with this data that is now changing and revolutionizing.
We truly believe is that we need to change our approach to data sets now. So far, the problem of the last 15, 20 years was how do we store data efficiently? How do we manage data efficiently? But now it's how do we access data proactively, right? We can't know what is all the data sets that are in these data lakes. We need to find a way to come with a business problem. And these various forms of AI need to help us to find the right data and then visualize the information or visualize the context that help us solve the business question.
Yeah, absolutely. We see this also as a big challenge within the EV charging space as well. Maybe one of the most practical applications of data so far that we've started to see emerge is how do you support operators in identifying the right sites and the right locations to put their charge points. And that's a business problem to try to maximize return from the heavy investment that you're going to be making on getting the land set up, redoing the infrastructure, getting the charge points installed. So it's also a huge challenge for us in the EV charging space. But then maybe Luca and Lukas, could you give us a few examples of what Sphere Energy is then trying to do to essentially close that knowledge gap? And what are some of the things that you have planned in the future?
Maybe we can start with our data infrastructure, right, that we built in our facility. So we have this tech center, battery tech center in Augsburg, where we test a lot of new technologies, a lot of prototypes, a lot of commercial cells as well. And before even buying those machines to test these technologies, we set up our data infrastructure, right? Because we always knew that the data points we collect through our services, through our projects, are becoming immensely valuable to us, right, to make us faster, more efficient. So we really rethought the way we set up the infrastructure to leverage these new large language models, to leverage these new transformer models, to interact with this data in a more natural way. To, as Lukas mentioned, to not have to know what we have in the data lake, but to only know what is the business problem I want to answer or solve, and let technology get access and calculate and plot the right data.
So can I ask where you originally got the data? What is the original source of this battery data?
Great question. Multiple sources. So we have customer projects, test projects. Obviously, that's for us locked, right? But we also have our own benchmarking tests that we do with technologies that we buy from the open market. But we also have other data points, such as the publicly available information, news, for example. So there are different data sources. Depending on the use case, depending on the business question, one or the other source is more important.
And our vision here is really to create a kind of virtual battery expert, right? That first internally helps us to become better, but then also we see more and more demand from our customers that would like to implement this virtual battery expert also on their side, leveraging their own data, amending it with external data, solving science-related or product development-related questions. Is it patent screening, data analysis, market screening? We have now a case potentially going on with a procurement team that is trying to look into what news is relevant for their negotiations, right? So there's so much stuff that we can amend our daily jobs with, and this is where we will put a lot of focus in the next couple of years.
So you're keeping us on the edge of your seats here. It sounds like there's something very exciting that's brewing. And I know, Luca, you shared some news very recently as well about a new product launch. So could you tell us, where are you starting? And is that the example of the problem that you're starting with in the procurement space?
So exciting news. As this episode goes live, Mike and Kevin, Batty will be available through our website for all your EV owners out there to just test Batty.
We haven't got any party poppers here, but just imagine that they're popping in there.
Batty is the first AI-powered product that we're launching to the market based on our infrastructure, but only based on one specific use case, which is battery news. So we are sourcing overnight, scoring and ranking publicly available news overnight and making this available as an interactive battery morning brief to the community for free. And with that, we really want to show the power of these new AI tools for the community, right? How this can make us better and faster.
And the idea here is not only to have this morning briefing, but you can actually interact with it. So you can exactly ask your questions, right? It should really help to educate not only everybody within the battery community, but also EV users, for example. Like when they read a news about Toyota's solid state battery, then they can ask basically Batty questions. What does that mean? What is the different specs of this battery? We're mixing in more and more scientific knowledge and knowledge from our own tests that we perform for us internally to really become and form a comprehensive battery brain that is really, so to say, a ChatGPT tailored to batteries, and that's really undergoing its battery PhD at the moment, as we say.
So the first, I guess, entity you could say that's going through this new vision that you have for best practice knowledge and the university itself is Batty.
Exactly.
Candidate number one.
Ask her any pressing battery-related questions, see how she does. We would love to get your feedback.
Fantastic. Thank you. That's really exciting.
So, Luca, we ask all of our guests that come on in between charges one final question.
What's the silver bullet?
What is the silver bullet? What does Batty say the silver bullet is? Now, we ask our guests, if you could bust one myth about EVs or the EV industry in general, what would it be? Luca, we'll go to you first.
Okay, I need to be careful that I'm not too bashy here, but I believe that recycling is part of the answer, but we still have a long way to go.
Do you want to expand upon that a little bit?
Sure, we can take another.
Well, because we hear about recycling a lot. We know that there's a lot more batteries are entering the market and everything. And a lot of EV naysayers often say, well, what about all the minerals associated with it? What are you going to do with all those used batteries? And I often reply, we're going to figure it out with the recycle. There's companies and really smart people out there working on the recycling problem. It'll be okay.
Yeah.
Now you're telling me that answer is not sufficient.
Well, it's definitely part of the answer. So I don't want to say we don't have to do recycling. We definitely need to do recycling. I think the question there is the business case behind recycling, especially when we talk about these new chemistries. LFP, Lukas touched upon it, all those chemistries that are not that valuable in the spot market, right? Who is paying for this recycling? And yeah, my personal opinion is that government subsidies need to play a big role in that.
Okay.
Fantastic.
Lucas?
Myth. So I would say that we should get rid of this whole breakthrough thing. Everybody's waiting for the next holy grail and talking about the next holy grail. There won't be a holy grail. It's tough. It's a lot of work. It takes time. So there won't be a silver bullet and a holy grail. We just need to work it through.
So you're shorting Toyota stock. Is that what you're saying?
Because I was told investment advice for me. It doesn't go well.
So this podcast does not provide any investment advice.
We're going to make the
disclaimer.
Disclaimer.
No, but that is, it does seem to be what Toyota is betting the farm on, basically, right? Because they've been they've been slow to dive into the EV world, right? Selling maybe 20, 30,000 last year in total. And then they have this breakthrough. They said, we're going to do solid state batteries. And everybody's gotten quite excited saying, okay, Toyota knows how to manufacture cars at an incredible scale. And if they can get this battery piece right, then maybe they're really going to be set on their way. But you don't think that solid state is going to be the real holy grail?
No, I don't think so, especially not for the EV market. We see that with QuantumScape, for example, now switching from EVs to consumer electronics, interestingly, because it seems to be very tough. I mean, also, the EV market is probably the most challenging one to get a battery through, right? The number of certifications you need to undergo and test is insane. So I don't think the solid-state battery is at least in the next 5 to 10 years, the holy grail for the EV market. Certainly not manufactured at this scale that we expect it to be a holy grail for.
Yeah, and I think there's also a question about what type of range is really necessary, right? I think it was the CEO of Ford or something was saying, we don't need to be talking about bigger and bigger batteries all the time, right? Need to be talking about how to facilitate and enable drivers to use a vehicle with a smaller battery because the charging infrastructure is better, right? That's what we work on here at Monta. But is 1,200 kilometer battery is what they're quoting as the range for Toyota. Is that necessary? Is that really going to facilitate and turbocharge EV adoption? Or should we be focused on different problems?
I think, to be fair, and that's only my opinion, I think we have seen the peak of range. probably a little bit more, but I think around 600 to 700 kilometers, we have reached a sweet spot between range and cost. I think now the OEMs are really thinking more about how can I reduce cost, because you have to imagine the battery is almost 50% of the production cost of an EV. So their problem is not how can I put more batteries in the car, it's like how can I put less batteries in the car. So I think we have seen the pinnacle of range, more or less, and I think we will more think about clever strategies and putting more charging points and charging faster and probably reducing price rather than increasing range.
Yeah. And I guess also just real practical applications of what type of battery should go where and what's the most efficient use of that battery, because what you might use in energy storage would be very different to what you have in an EV powertrain. Great. Okay. I think that's a really great time to round off the episode. So Lukas, thank you very much for coming into our humble studio and giving us a really great discussion about the world of Sphere Energy and your point of view on how we can solve for energy storage and battery strategy going forward.
Thank you for having us.
Thanks for having us, guys.
Check Batty out.
Thanks very much for tuning into today's episode of In Between Charges. Today we had a great discussion about battery strategy, how organizations can and should become battery first, and also thinking about comprehensive views of the most efficient purchasing strategy and implementation strategy of a battery. There's not one silver bullet, and I think that wraps up the whole episode itself. Follow us on your favorite social media platform, give us a 5-star rating where you've listened to this podcast, and tune in next time.